Hey everyone, welcome back to the Deep Dive. We're diving deep into another fascinating topic today.
That's right. We're going to be taking a deep dive into stress testing in software, which I'm excited to talk about.
We all use software every single day, like constantly, but I don't think we often think about what happens when it gets pushed too far.
Yeah, that's exactly what stress testing is all about, making sure your software can handle the heat when things get crazy.
And to do that, we've compiled a bunch of really interesting material to really understand how this works and why it matters.
Absolutely. Today we're going to break down what stress testing is, why it's so important, and what we can actually learn when we try to break things on purpose.
So, you've probably heard the term stress test thrown around, but what exactly does it mean when we're talking about software?
Well, when we talk about stress testing software, we're essentially trying to see how much it can take before it breaks.
Okay, so like really pushing it to its limits. Exactly. We're talking about hitting it with way more traffic or data than it would normally see, kind of like simulating a worst-case scenario.
So it's not just about making sure it works under normal conditions, it's about seeing how it holds up under extreme pressure.
That's it. The main goal is to make sure that even when things get really intense, the software can still function and ideally recover gracefully.
Right, because in the real world, things don't always go perfectly, right?
Absolutely. And that's why it's also sometimes referred to as endurance testing. We're looking at how long it can withstand these tough conditions.
Okay, I'm starting to get the picture, but can you give me a real-world example of this? Something everyone can relate to.
Sure, think about it this way. Um, have you ever tried to download a really, really large file, like say a huge movie or something?
Oh, yeah, definitely.
And maybe at the same time, you've got like a ton of other programs running on your computer and your internet connection is maybe not the greatest.
I can picture it now.
Suddenly, everything just starts to slow down, right? Like your computer freezes and you get that dreaded not responding message.
Ugh, the spinning wheel of doom. We've all been there.
That, in a very basic sense, is what stress is like for your computer. And in software, stress testing is about finding those not responding moments before they happen to real users.
So we're intentionally causing those problems in a controlled environment so we can fix them before they become a real issue.
Exactly. We're trying to break it in the lab so it doesn't break in the wild, so to speak.
Makes sense. But why go through all this trouble? I mean, why try to make software fail on purpose?
Well, the real world can be unpredictable, right? Think about what happens when a popular website has a big sale, like on Black Friday.
Oh, yeah, the traffic must go through the roof.
Exactly. Or what if a news website breaks a huge story? Or a government website releases exam results? These systems can be hit with a massive influx of users in an instant.
Right, or even something like concert tickets going on sale.
Precisely. And if those systems aren't ready for that, it can lead to a whole bunch of problems.
Like websites crashing, frustrated users, people missing out on things they really wanted.
Yep, all of that. And even worse, it can lead to lost revenue and damage to a company's reputation.
So stress testing is kind of like a preventative measure, right? You're trying to identify weaknesses before they cause a real disaster.
Exactly. It's like a fire drill for your software. We want to make sure it can handle the heat.
So it's not just about whether it breaks, it's about how it breaks and how quickly it can recover.
That's right. And speaking of breaking, we're not just trying to see if it stays online. We also want to know if it displays clear error messages when things go wrong.
Yeah, that's a good point. There's nothing worse than getting a cryptic error message that tells you nothing.
Absolutely. We want users to know what's happening even when things are going haywire.
Makes sense. So we've talked about why we do stress testing, but what are we actually trying to learn from it? What are the specific goals?
One of the biggest goals is to understand how the system behaves after it fails. Does it crash and burn? Does it lose data? Can it recover gracefully?
Right, because even if it fails, we want it to fail gracefully.
Exactly. We want to make sure it doesn't take down the whole system with it.
Okay, so it's about understanding the breaking point, but also what happens after the break.
And another key concern, especially when we're dealing with sensitive information, is data loss.
Yeah, that's a big one.
We need to make sure that even under extreme stress, critical data remains protected.
No data breaches, even when the system is being pushed to its limits.
That's the goal. And finally, we want to see how quickly the system can recover after the stress is removed.
So it's not just about surviving the punch, it's about getting back up quickly.
That's a great analogy. We want systems that are resilient, adaptable, and can bounce back from tough situations.
Okay, so that's stress testing in a nutshell. But I often hear people use the terms load testing and stress testing interchangeably.
Right, and it's an important distinction. While both involve testing the system's performance, they have different aims.
Yeah. So what's the difference?
Load testing is about simulating normal or expected peak conditions. It's about seeing how the system performs under typical everyday use.
So, like making sure the website can handle a busy Saturday afternoon.
Exactly. Stress testing, on the other hand, is about pushing the system far beyond those normal limits, intentionally trying to make it break.
So, load testing is like seeing if your car can handle a highway drive, while stress testing is seeing if it can survive a demolition derby.
That's a pretty good way to put it. Load testing is about measuring performance under normal circumstances, while stress testing is about finding the breaking point and seeing how the system copes with extreme situations.
Okay, that clears things up. Now, let's dive into the different ways you can actually do stress testing. What are some of the approaches?
Well, there are quite a few different types, each designed to target specific aspects of the system.
So, like different tools for different jobs.
Exactly. One common approach is called distributed stress testing. This is where you simulate stress from multiple sources, like multiple users accessing the system at the same time.
So, it's like having a whole crowd of people all trying to use the same website or app at once.
Exactly. This helps us understand how the system handles heavy traffic and ensures it can distribute the load effectively.
Okay, what else?
Another type is application stress testing. This focuses on a specific application and looks for things like bottlenecks, data locking, and other performance issues.
So, it's like zooming in on one particular piece of software and putting it through the ringer.
Precisely. We want to find those weak points within the application itself.
Got it. What other types are there?
We also have transactional stress testing, which focuses on testing specific transactions within a system.
So, like making sure that online purchases go through smoothly, even when there are a lot of people buying things at the same time.
That's a great example. We want to ensure that those critical processes can handle the pressure.
Makes sense. And then there's systemic stress testing, right?
Right. Systemic stress testing is about testing multiple interconnected systems at the same time.
So it's like seeing how well all the different parts of a website work together under stress.
Exactly. We want to make sure that one system under stress doesn't cause a domino effect and bring down other systems.
So it's about understanding those dependencies and making sure the whole system is resilient.
That's the idea. And finally, we have exploratory stress testing. This is where things get a bit more creative.
Oh, this sounds interesting.
It's about testing unexpected scenarios or conditions that might not normally occur.
So, like, what if someone tries to log in with the same password 1,000 times in a row?
Exactly. Or what if the database connection suddenly drops while the website is experiencing peak traffic?
Okay, so it's about trying to anticipate those weird edge cases that could potentially cause problems.
That's right. We want to find those hidden vulnerabilities that we might not have thought of otherwise.
So we've covered the different types of stress testing, but what about the process itself? How do you actually go about doing it?
Well, there's a general framework that most stress tests follow. It starts with planning, where you gather information about the system and define your goals.
So like figuring out what you want to test and what you're hoping to learn.
Exactly. Then you need to create scripts that will automate the testing process.
Scripts, like little programs that do the testing for you.
Precisely. These scripts will simulate the user actions and generate the load that you want to put on the system.
Okay, so it's not like you're sitting there manually clicking buttons a million times.
No, definitely not. Automation is key for this kind of testing. Once the scripts are ready, you execute them and monitor the system's performance.
So you watch as the chaos unfolds.
In a controlled way, yes. You're looking for bottlenecks, slowdowns, errors, anything that indicates a problem.
Okay, so you gather all that data, then what?
Then comes the analysis phase. You dig through the results, looking for patterns, and trying to identify the root causes of any issues you found.
So you're playing detective, trying to figure out why the system broke.
Exactly. And based on that analysis, you make recommendations for improvements, like code optimizations or configuration changes.
So it's a cycle of testing, breaking, analyzing, and fixing.
That's right. You keep iterating until the system meets your performance goals.
Now I'm curious about the tools that people actually use for stress testing. What are some of the popular options out there?
There are a number of really good tools available, both commercial and open source. One of the most widely used is LoadRunner.
I've heard of that one.
It's a very powerful tool, especially for testing complex enterprise applications. You can simulate a huge number of users and provide detailed performance metrics.
So it's like the industry standard for stress testing.
It's definitely one of the most popular choices. Another good option is JMeter, which is an open source tool that's very versatile.
I like that it's open source, makes it more accessible.
Absolutely. And it can handle a variety of different testing scenarios, from load testing to functional testing to stress testing.
So it's like a Swiss Army knife for software testing.
That's a good way to put it. And if you're looking for something that's more focused on web application performance, there's Stress Tester.
Stress tester, okay. What's that one good for?
It's really good at identifying bottlenecks and performance issues in web applications. It provides easy-to-understand reports and doesn't require a lot of scripting knowledge to use.
So it's more user-friendly.
Definitely. And lastly, there's NeoLoad, which is another commercial tool that's great for testing web and mobile applications.
Neoload, okay. What sets that one apart?
It's known for its ease of use and its ability to simulate a large number of users across a variety of different devices and platforms.
So it's good for testing applications that are used on multiple devices.
Exactly. And it integrates well with cloud-based testing environments, making it very scalable.
So a good mix of options depending on your needs and budget.
Exactly. Now, once you've run your tests, you'll have a ton of data to analyze. But how do you actually measure success? What metrics are you looking at?
Right, because data without context is just noise.
That's true. The metrics you use will depend on the specific goals of your test, but there are some common ones that are useful in most cases.
Like what?
Well, one important category is scalability and performance. This includes metrics like pages per second, throughput, and rounds.
Okay, break those down for me. What do those tell us?
Pages per second measures how many web page requests the system can handle successfully each second.
So like how many people can visit the website at the same time without it crashing?
That's the idea. Throughput measures the amount of data the server can send back per second.
So how quickly can it deliver information to the users?
Exactly. And rounds compares the number of planned test scenarios with the number that were actually completed successfully.
So it's a measure of how well the system performed overall.
That's right. We want to make sure that the majority of our test scenarios are completed without any major issues.
Okay, makes sense. What other categories of metrics are there?
Another important category is application response. This includes metrics like hit time, time to the first byte, and page time.
Okay, so these are more about the user experience.
Exactly. Hit time measures how long it takes to retrieve a single resource from the server, like an image or a file.
So like how quickly does the image load on the page?
Precisely. Time to the first byte measures how long it takes for the server to send the first piece of data back to the client after a request.
So it's a measure of how responsive the server is.
Exactly. And page time measures how long it takes for the entire web page to load.
So these metrics help us understand how quickly the user sees the content they requested.
That's right. And the faster the better, because users are not known for their patience.
Definitely. Now, what about failures? What metrics help us understand when things go wrong?
Well, some key metrics for failures include failed connections, failed rounds, and failed hits.
Okay, so these tell us how many things went wrong during the test.
Exactly. Failed connections measure the number of attempts to connect to the server that were rejected.
So like if the server is overloaded and can't handle any more connections?
Exactly. Failed rounds tell us how many of our planned test scenarios fail to complete successfully.
So it's a measure of how many tests didn't pass.
That's right. And failed hits measure the number of requests for specific resources, like images or links, that resulted in an error.
So like if you click on a link and it leads to a 404 error.
Precisely. We want to minimize these failed hits as much as possible.
Okay, so by analyzing all these metrics, we can get a pretty good picture of how the system performed under stress.
That's right. We can see where the bottlenecks are, how the system recovers from failures, and how the user experience might be affected.
And that helps us make improvements and ensure that the system is as resilient as possible.
Exactly. The goal is to find and fix those weaknesses before they cause problems in the real world.
So to wrap things up, what are the key takeaways about stress testing that everyone should remember?
Well, first and foremost, stress testing is about pushing the system to its limits to see how it behaves under pressure.
Like a digital trial by fire.
That's a good analogy. We want to see how it handles the heat, and we want to make sure that it can recover gracefully from failures, that it displays clear error messages, and that it doesn't lose critical data.
So it's about building systems that are robust, reliable, and can handle the unexpected.
Exactly. And remember, stress testing is especially important in today's world where we rely so heavily on digital systems.
Absolutely. Think about all the things we do online these days. shopping, banking, communicating, working.
And all of those systems need to be able to handle the pressure, especially during peak times.
So stress testing is about ensuring that those systems are up to the task and that they can provide a seamless experience for the users.
That's right. It's about building systems that can handle the real world with all its complexities and challenges.
Well, I think we've covered a lot of ground today. Thanks for taking us on this deep dive into the world of stress testing.
It's been my pleasure. It's a fascinating topic, and I hope our listeners found it insightful.
And to our listeners, we leave you with this thought. As we become even more reliant on technology, how can understanding the breaking points of our systems shape not only how we build them, but also how we interact with them?
It's a question worth pondering. Thanks for listening.
We'll catch you on the next deep dive.